Okay, so welcome everybody. So let me introduce myself before we begin the slides. I'm Dolev. I'm currently working at Wix. I've been there for about 1.5 years. I'm a front-end developer at the Velo team. Just for those who don't know, Velo is a full-stack development platform that allows users to write custom logic on top of Wix's WYSIWYG editors. My specific team is working on the online code editor itself and its auto-completion engine. And for anyone interested in learning more, just feel free to reach out. Cool. So recently I've been basically falling in love with the CLI. I went through a rabbit hole of trying to make my developer experience better and found that a lot of the stuff are snappier to do on the terminal. On top of that, there have been a lot of innovation surrounding the terminal. So hopefully I can convince you to give the terminal more attention and that I find it rewarding. So let's talk a little bit about the innovations that I mentioned. You might think that the terminal is a boring interface and kind of depressing to stare at all day. Well, actually it can be glamorous. If we go to one of the companies that has a lot of innovation in the field is called Charm. Let's actually open up their website. And you can see they have a lot of libraries. Each one of these is a library that allows you to do crazy stuff on the terminal and also make it beautiful. Charm is a fairly new startup that wrote a bunch of libraries to help us make the terminal less boring. And we'll see some of those libraries later on, so no spoilers. In the 2016, Microsoft launched the Windows Subsystem for Linux, WSL, which basically lets Windows users run a GNU/Linux environment, including most of the command line tools you all know. And they also launched the new Windows Terminal. And then, as you can see, the terminal, the Windows terminal, the one that you're used to, called CMD, looks pretty different than this one. This one actually looks good. And it has a lot of the newer features that you'd expect from a terminal. And the last startup that I want to talk on is called Warp. And they're basically reimagining the terminal. If we go over to the website, you can see the terminal looks completely different. This is like an example for a terminal. You can edit commands like you're in VS Code with multiple cursors. You get auto completions, basically like IntelliSense. And you even have like a GitHub Copilot kind of thing for auto-completing commands using AI. So let's talk briefly about what are the benefits. What are some of the reasons you'd want to spend more time on the terminal? First of all, CLIs are a great way for telling computers exactly what to do. Unlike GUI applications where a bunch of different workflows are hidden behind a naive-looking button. Secondly, they're composable. That's basically the Unix philosophy. Write something that does one thing and does it well. You can then pipe one command output to another input to compose more complex pipelines. Another point is for those that care about ergonomics and staying on the keyboard for speed. What I mean is you move less between the mouse and the keyboard, basically. Terminal is a better choice because you obviously have to do stuff on the keyboard. The shell is the closest thing to the OS, so you can easily interact with it, files, network, etc. very easily with the built-in GNU utils. And many times GUI apps exist solely as friendlier but weaker versions of a CLI app. Knowing the CLI version gives you way more power and granularity, and as a developer you're already in the CLI a lot, so why not learn to master it? And I want to finish up with a quote. The problem with what you see is what you get is that it is usually equivalent to what you see is all there is. Okay, so let's see some cool example of stuff you probably didn't know you could do in terminal. First up, you can actually draw in the terminal. And you can even celebrate wins with some confetti. You can play magic tricks. Let's pick, I guess, 4 diamonds. How the hell did it know? I've included some of the bash script here. You can see one of the libraries that Charm made, one called Gum. Gum lets you easily create user interactable scripts, which also look good. And the code here is quite simple. You can use GUM, choose to answer a couple of questions, basically the card that you picked. You can then print the chosen card with GUM style, as you can see here, and give it a nice rounded border, etc. So this is a way to easily write bash scripts that also look good. Let's try to understand how the terminal actually works. The most basic term we need to learn about is escape sequences. ANSI escape sequences are standard for signaling terminal emulators to do special things. Terminal emulators are the programs that render the user input and the commands output. They send the input to a program called the shell. In my case, it's fish, but it can be ZSH or bash. And terminal then interprets those sequences as commands rather than display the text as is. Okay, so let's see an example of an escape sequence. Okay, so here's one. The first few characters lets the terminal know this is the start of an escape sequence. It's basically the escape key represented in a string. There are actually multiple ways to write escape. It's octal or hex notation, as you can see here. And right after that, there is a separator, the square bracket, and then the list of display attributes, each separated with a semicolon. And finally, M represents the end of the sequence. Below is a table of some of the display attributes. In this example, we set 1, so the text is bold, and 31, which corresponds to the color red. So running the example from earlier, this time with octal notation, we get a bold red text. The 8-color display attribute I showed earlier is a bit limiting. We also have support for 256 color support in most terminals. It's called the ANSI color. Here's a simple Python script to display all 256 colors. Okay, and some terminals, newer ones, actually support true color, among with other features like strike through, dotted underlines, etc. Here's a simple script to test your terminal's capabilities. So we can see it's printing all the basic 8 colors and all the ANSI colors and even true color gradients and options like underline, double underline, undercurl, and true color underline, etc. Using escape sequences, we can also control where characters are printed. The H command lets us specify coordinates. Without any arguments, the default is 0, 0, basically the top left corner. And in the second example, I'm printing 3 cats spaced 5 columns apart horizontally. So if we run this, you can see, oh my god, it's printed at the top left and the cat's printed down here. Okay, so now that we have a low-level understanding of how terminals basically work, let's forget all that and use a bunch of libraries and make it a lot easier. We're going to write a simple app called Roulette. The app can help you randomly choose between different items, like what to eat for dinner or who's next to go in the daily, etc. The libraries we're going to use are from Charm, so to write the app, we need to learn a bit of Go. We're going to use the Elm architecture used by Charm's BubbleTea lib, and we're going to use their Glamour libraries. Here's an example of what the finished app would look like. We can pass in options as standard input, and we get the roulette spinning. Once we press Q or Control C, we get the winning item. We can simply SSH to git.charm.sh, and we can read each lead's README. Here we can see all of the libraries. The library that's actually running now is called Wish, and as you can read in the README, it basically makes SSH apps very easy to create, just like this one. Now, to use Charm's libraries, we need to have some Go knowledge. Again, we're going to use the terminal for that. So for those unfamiliar, cheat.sh is a site that's built for consumption of the terminal. You can write something like cheat.sh go /learn to get the basics of Go. So if we actually skim over this, we can see how to write a function with the func keyword, or how to define variables. And one last concept that we need to know is how to define a method on an object in Go. So basically, as you can see here, we're defining the string method over an object of type pair, and then we can call on every pair, we can call this method. And by implementing the string method, we're actually satisfying the stringer interface, which says that every object that has a string method that returns a string is of a stringer type. Okay, so we will use this knowledge to write our Bubble.t application. Okay, so one last concept we need to know in order to use Charm's Bubble.t lib is the Elm architecture. You can think of it like a React app lifecycle. And Bubble.t's runtime that's used to run our app uses this architecture. So we first need to define a model, and this model represents our app state. It's a simple object we define, and in it we need to store all the information we need to render our UI. And given a model, the Elm runtime calls our view function, which we use to return a string. And remember, terminals only display text, so that string is actually our UI. Now that we know that given a model, we render a view, we need a way to change the model. That's where the update function comes in. This function receives a message when things happen. Here, we write logic to update the model, depending on what happened. And messages are the way we declare what happened. User input is just one thing that might happen, but it could also be a timer firing, a network call that was returned, or a file read from disk. In addition to that, the update function can return commands. And commands are functions that Bubble.t runs for us asynchronously. These functions return a new message, and those messages will also eventually be sent to the update function to create our runtime loop. Now let's see how to use Bubble.t to write our app using the Elm architecture. So for our roulette app, we need a very simple model. We first need to hold the options the user passed in when they ran the app, and then we only need one more property, current ID, which is the current tick cycle the app's in, as the roulette we're going to build is spinning and the options are rotating around. Next, the update function. This function, as we said, receives the current model and a message of what happened. It then returns the updated model. It can produce additional messages with something called a command, and we'll see it later in action. The final piece of the puzzle is the view method. We simply need to return a string here, and Bubble.t takes care of the rest. This is roughly how our code would look like. Let's start writing the app. Okay, so this is a simple main function. It basically reads all the args that were passed in and starts the Bubble.t app. Let's go into the main file of the app. Okay, so when the app starts, it calls the initial model method, which basically returns the model. Okay, so as we said, we need to save the options on the model. And then when initial model is called, we need to save them on the model. Our update function is currently very simple. All it does is look at the test message that was received, checks if it's a key message, which means the user pressed a key, and then compares it to either Control-C or Q and quits the app if it was the case. Our view function is just a simple printing of hello world. Let's run our app and see what happens. It just prints hello world, and when we press Q, we're out of it. So first we're going to need to print the options. So in our view function, let's move this line and make a new array that will hold the range of options. We'll make a string slice in the size of the len of the options. And we're going to iterate over the options and print them out. We're then going to use one of Charm's libraries called libplus to format our output a bit, so it looks nicer. We're going to use the join vertical method, which allows us to easily join a couple of strings. And we're going to pass in all of the options. Let's see how it looks right now. Right, we need to go get lip gloss. And then run it. As you can see, they are neatly printed line by line. Next up, we want to be able to basically rotate the options every, let's say, 80 milliseconds, so it looks good. And we are going to do that with the update function. When the app starts, we want to fire a message, and we do that with the init method. So let's write a new function called doTick, which basically returns a t.command, and we'll explain later what t.command is. But we're going to use the t.tick method in order to fire a new message every 80 milliseconds. And t.command is basically a function that returns a method. It allows us to fire new messages asynchronously. So let's write a new function which adheres to what t.tick expects to receive. And we're going to return a new message called tick message. Let's define this object. And when the app starts, we want to fire this method to start the app spinning. So now one of the messages that we can receive is the tick message. So let's handle it. When the tick message is received, you want to fire another tick message. So the app keeps spinning and spinning, okay? So let's return m and fire another tick message. Before we fire the tick message, we want to update our model to actually say that a tick happened. So we're going to update our current ID. And let's add it to our model. To be 1 plus whatever it was. And we don't want to forget to modulo so we don't overflow. Okay, so if we print out our current tick, let's do it simply by doing fmt.printf. And see what happens. You can see the tick keeps spinning around, but doesn't ever go above the number of options. This is exactly what we want. You can think of it as the selected item, the winning item. Okay, so let's delete that for now. So let's give our app some more style. We're going to create a couple of styles using lip gloss. And lip gloss allows us to create styles using CSS notation. So we're going to give them the items some padding horizontally, and then some predefined width, so they all fit nicely. And we're going to set the height to 1. And finally, we're going to align stuff to the middle. We also want another style for the selected item, so it pops out. So we're going to copy the style of the regular item, but we're going to change some stuff up. We're going to give it a more prominent background. And we're going to use the ANSI color red for that. And some foreground color. We're going to use black for that. And we're going to make it bold. Cool. Now that we have those styles, let's apply them to our options in the view method. We're going to create a style variable. And then depending on if it's the middle item, we're going to give it a different style as we'll define the item in the middle to be the winner. And then we're going to use lipgloss again to render our item with the given styles. Okay, so let's see how it looks. Oops. Cool. Okay, now let's use the current ID to actually spin the items around. So instead of taking the option as is, like we do on line 77, we're going to actually take the option with the offset of the current ID. So we'll take the options, and we're going to use I plus the offset, which is current ID. So we don't overflow. Okay, cool. And then we're going to render the option. So let's see it in action now. And as you can see, the items spin around, and whenever we click Control C or Q, we get the winner. So this is just a simple example, but if we want to take it to the next level, we can actually make it look prettier, and I'll have the final code up on my GitHub, so you can check it out. The final product, which looks like this and runs with real physics. The physics come from another library from Charm called Harmonica, which you can use to easily get a spring animation. And looks like tonight we're going to eat pizza. So thank you very much. These are all the resources. You can also easily find the presentation. I'll put it up on my GitHub and the final code. Please check out all the libraries and have a good one. Bye.